Hello friends, in today's session we are going to explore many more topics related to event handling. Okay, so we were seeing about the key listener interface in previous session. We will continue with that. This key listener interface has three methods: key pressed, key released, and key typed. Okay, so key pressed and key released are invoked or called when a key is pressed and released respectively, and key typed is invoked when a character has been entered. For example, if user presses and releases a key, three events will be generated: key press, type, and key release. If a user presses and releases the home key, two key events are generated: key pressed and key released. Okay, so general formats of these methods are void key pressed, key event key, void key released, key event key, and void key typed, key event key. Next is mouse listener interface. This interface defines 5 methods. If the mouse is pressed and released at the same point, mouse click is invoked. Okay, so pressed and released at the same point or at the same x and y coordinates, mouse click method is called. When the mouse enters a component, mouse entered method is called. Means if the mouse is entered in the text field area or text edit text area, then it will be calling the mouse entered method. When it leaves, mouse exited is called. That is, if it is exiting from the area of text field or edit text, the mouse exited method is called. The mouse pressed and release methods are invoked when the mouse is pressed and released respectively. So these general formats are void mouse click, mouse event me, void mouse entered, mouse event me, void mouse exited, mouse event me, void mouse press, mouse event me, void mouse release, mouse event me. So all these are having only one parameter object of mouse event. Okay, so you have to remember these methods. You can by heart them or you can take a screenshot. Okay, mouse motion listener interface. Okay, so this interface defines two methods: the mouse drag and mouse move. Mouse drag is called multiple times as the mouse is dragged. Okay, so what is dragging? When we are clicking at the left place and from the right, but at the right side we are dragging and creating the position. For example, when you are cropping the image in the PC, for example, you are clicking at particular x and y coordinate and clicking of the left mouse button, and then you are pulling that mouse in the downward direction so that a particular area of that picture is taken to crop. Okay, so background is removed in this case and only the image that you want to gain is gained properly. Okay, so that event is called mouse drag event. And mouse moved is called multiple times as the mouse is moved. Every time the cursor is moving on the screen, every time mouse moved is called. Okay, so mouse dragged is also mouse motion listener, but with a left button click of a mouse, and mouse motion or mouse move is every time the cursor is moving. Two forms are there. General forms are void mouse drag, mouse event me, void mouse moved, mouse event me. Okay, mouse wheel listener interface. This interface defines the mouse wheel move method that is invoked when the mouse wheel is moved. So we have seen in the previous session that previous to previous, I guess, or the first session, I guess, that is not every mouse has a wheel. Okay, so if any mouse is having particular wheel, that wheel will be between the left and right button of the mouse. Okay, and those mice only who have the wheel inside them will be able to call this interface, that is mouse wheel listener interface. Okay, if you are implementing the interface in your class, for example, my class implements mouse wheel listener. Okay, so now not every PC will be able to run that project. Not every PC, only the PC that is having the mouse and who is having the wheel, that will be only able to call this class or actually use the class object. The format is void mouse wheel move, mouse wheel event me. MWE. Okay, the text listener interface. This interface defines text value change, that is invoked when the change occurs in the text area or text field that we have already seen. Already contained text when that is the default text when the graphical user interface is first time loaded on screen. That text is not be considered as a event or text listener event. Okay, text event, text change event. So this actually text value change method will call when you are actually doing anything, something like you are changing the value inside that particular area. The format is void text value change text event T. Okay, window focus listener interface. This has two methods: window gain focus and window lost focus. Okay, so they are called when the window gains or loses input focus. These general forms are window gain focus window event and window loss focus window event WE. Window listener interface has 7 methods. Window activated and deactivated methods are invoked when a window is activated or deactivated respectively. If a window is iconified, the window iconified method is called. When a window is de-iconified, the window de-iconified method is called. Okay. When a window is open or closed, the window open or window close methods are called respectively. The window closing method is called when a window is being closed. Okay. The general formats of these methods are window activated, window event WE, window close, window event WE, window closing, window event WE, window deactivated, window event WE, void window de-iconified, window event WE, void window de-iconified, window event object, and window open. Okay. Using the delegation event model, that is one is source and another is listener. Now that you have learned the theory behind the delegation event model and have had overview, like we have already seen what is delegation event model. One is a source who generates the event, and another is a listener to handle the particular event. Okay, so we will now actually implement in practical part. Okay, using the delegation event model is very easy. So what we have to do, implement the appropriate interface in the listener so that it can receive the type of event desired or interested. Okay, so first of all, what you have to do, create the source, then create a listener that implements the particular interface. Implement code to register and unregister the listener as the recipient for the event notification. Okay, so what you have to do is register and unregister the listener. Okay, so when a listener is interested, it can register for the event, and if it is not interested, it can unregister from the event. Okay, as a recipient of the event notification. Source may generate several types of event. It is up to the listener which type of event he is interested to listen or handle. Okay, so up to the listener. So there are multiple types of listener you can create who actually implements the interface. And what source will do? Source will call the method inside the listener, so that using that particular object, listener can actually handle the event. Okay, each event must be registered separately for separate listeners. Also, object may register to receive several types of event, but it must implement all of the interfaces to receive these events. Okay, one object can have multiple interfaces implemented, and if it want to handle all the types of event generated by source, it must implement the interface and must create and write down the code to handle that particular event. In all cases, event handler must return quickly. An event handler must not retain control for extended period of time because user will not wait. Okay, so it should be as small as possible. It should be in seconds. Okay, it should handle the event and return quickly. To see how the delegation model works, we will see now two command event generator, mouse and keyboard. Okay, So now we will see some key AWT GUI concepts. Okay. So now we will see the fundamentals of event handling. We will use simple GUI based programs. Simple programs you will see, so that you will understand. If you will understand it better, you will be able to build more complex GUI programs. Okay. Most events to which your program will respond will be generated by user interaction with GUI programs. Okay. Although the GUI programs in this chapter are very simple, it is still necessary to have few key concepts explained related to GUI based programs, because they differ from the console based programs found in the many other chapters of this particular course. Okay. So for building small simple GUI based programs, we have to first differentiate the console based program and GUI based program, because the functionality is different. The way they actually implement the events are different. It is important to point out that all modern versions of support of Java support GUI frameworks. That are two GUI frameworks. First is AWT and second is Swing. Swing is most generally used, but still AWT is supported. AWT was Java's first GUI framework, and for very limited GUI programs, it is the easiest to use. Okay, Swing, which is built on the foundation of AWT, was Java's second GUI framework. It is founded by AWT itself and was Java's second GUI framework, and is the most popular and most widely used. Okay. For simple ones, we will use the AWT based programs, and for the complicated ones, it is made easier by using Swing. So you will have the Swing particular code. A third Java GUI code called JavaFX was provided with the several recent versions, but beginning with Java 11, it is no longer part of the JDK. Both the AWT and Swing we will discuss later. We will here only demonstrate related to keyboard and mouse events. Okay. Simple. So to understand the fundamentals or basics of event handling of practical part, what we will do, simple AWT based GUI programs are an appropriate choice and are used here. Okay. So there are four key AWT features so that we will use. First, all create a top level window by extending the frame class. Top level window is outer window. You have to extend the frame. Frame defines what one would think of it as normal window, basic window. It has minimize, maximize, and close boxes. Like we are opening Paint, we can minimize the Paint window, we can maximize the Paint window, we can close the Paint window. It can be resized, covered, and displayed. Okay. So when it will be covered, it can be covered by any other program that is running outside, and redisplayed. We can minimize the other window and redisplay the current one. Second, all override the Paint method to display output in the window. First is what you have to extend, frame class. Second is you have to implement the Paint method. What Paint method will do, actually paint the GUI components inside the container, so that you will see the output as a combination of buttons, radio boxes, check boxes, text area, and so on and so on. Okay. This method is called Paint method. Is called automatically. You don't have to call it. It will be called automatically by the runtime system to display output in the window. For you have to do is you have to just implement or override the Paint method. It is compulsory for all programs. Note it down. Okay. And you don't have to call this method. It will be called automatically. It is called when a window is first shown and after a window has been hidden and then uncovered. Every time, first it is when you are running the program, first it is displayed. It will call the Paint method. When it is minimized and then maximized, then also this Paint method will be called. When your program needs output displayed, it does not call Paint directly. Okay. So in the particular case, when your program needs output to be displayed. It does not call paint directly. Okay, you call repaint. Repaint will explicitly call paint method. Repaint tells the AWT call paint. First time paint will be called. Second time repaint will be called. Repaint will then tell the AWT to call the paint. This is the way. You will see how the process works in the examples we will see now. When the top level frame window for an application is closed, for example, when you are clicking the close, suppose you are opening the paint in your computer and you are clicking the close button, this outer window is closed. The program must explicitly exit often through a call to system.exit. Okay, when it is closed, it must close the window. Clicking the close box by itself does not cause the program to terminate. Okay, so you have to write down there the line system.exit semicolon. It is necessary for AWT based UI program to handle window close events explicitly. You have to write it. Okay, then handling mouse events. To handle mouse event, you must implement mouse listener interface and mouse motion listener interfaces. You may also want to implement mouse wheel listener, but we won't be doing so here. Okay, so it is your choice if you want to implement that. If your PC, if your particular PC is having mouse which is having a wheel in that, or you want to create a program or build an application for that PC, whoever is having wheel in that mice. In that case, it is your choice. You can implement the mouse wheel listener interface. Okay. So here what we will understand, mouse listener and mouse motion listener interface implementation. It displays the current coordinate of the mouse in the program window. Coordinates X and Y. The top left X and Y coordinates are 0 and 0. Each time a button is pressed, the press button down is displayed at the location of the mouse pointer. Okay, button down means button pressed, button released is button released. Okay, button when you are releasing the button release is shown on the location of the mouse pointer. If the button is clicked, a message stating this fact is displayed at the current mouse location. That is, button is clicked. As the mouse enters or exits the window, message is displayed that indicates what happened. Okay, so what we are going to implement here, every time when the button will be pressed, we will write down button down. When button is released, we will write down button release. When button is clicked, we will write down button is clicked, and enter exit is also displayed. When dragging the mouse, A is shown which tracks the mouse pointer as it is dragged. Notice that mouse X and Y, that is X and Y coordinates variable, store the location of the mouse when the mouse press, release or drag event occurs. So when the pressed event is occurred, its X and Y coordinate. When release event occurs, its X and Y coordinates, and drag event occurs, its latest X and Y coordinates will be stored in the variables mouse X and mouse Y. These coordinates are then used by paint method to display output at the point of these occurrences. Okay, so we will start with this two interfaces implementation. Mouse events demo extends frame, implement mouse listener, mouse motion listener. Message is here, X and Y coordinates to store the X and Y coordinates. Then mouse events demo. Add mouse listener, add mouse motion listener. Because this is implementing these two interfaces. Add window listener, new my window adapter. Okay. Okay. Then mouse click, mouse event emit. So message will be updated. Message click receive. Mouse click on mouse entered. Mouse and X and Y coordinates are 100 and 100 and call the repaint method. Mouse exited, repaint is called. Mouse pressed, me.getX. So me is the object where we are pressed the mouse. Get X coordinate, get Y coordinate are stored. Button down, repaint. Okay. Then handle button released. Public void mouse release, mouse event me. Save coordinates. Okay. So when released, the x and y coordinates are saved. Mouse x, mouse y. Message is equal to button release, repeat. Okay. Then mouse drag, mouse event me. Save coordinates x and y coordinates and message start mouse at mouse x and mouse y, that is x coordinate plus y coordinate, and call the repeat. Mouse move, this is the object, get x coordinate, get y coordinate, then call the repeat. Okay. So you have to only implement the pend, and in all other cases repent will be called, and it tell the AWT to call the pend method. Public void pend, it is the compulsory method you have to implement or override. You have to pass the graphics object. G graphics object dot drawstring message mouse x mouse y. Okay. Mouse events demo. This is the object of the class. This is the class we have created, mouse events demo. Okay. We are creating its object in the public static void main. So here it exists, public static void main. App win is equal to new mouse events demo. Then set size, set title. Size is equal to 300. Okay. Then title is mouse events demo. Set visible is equal to true. When the close box is clicked, close the window and exit the program by system.exit 0. Okay. My window adapter extends window adapter and override the window closing method. Pass the window event object. Okay. So this is the output we are having over here. Mouse event demo, moving mouse at 11920. These coordinates can change depending upon where I am clicking on the surface of this outer window, that is called as frame. And depending upon the clicking and in your side, when you will be building this program at your side in Eclipse and you will be running, suppose you are clicking here, my cursor, you can see my cursor, you are clicking here, this x and y coordinates will be different, this x and y coordinates will be different, this x and y coordinates will be different. So depending upon where you are clicking, it will display its x and y coordinates. Okay. Next. So first you have to take down that mouse x events demo extends frame for the creation of outer window. It forms top level window or outer window for the particular application. Mouse listener and mouse motion listener interfaces we are implementing. ML is a reference to object receiving mouse event, and MML is a reference to object receiving mouse motion event. Okay. The same object is used for both the purposes. Mouse events demo implements all of the methods defined by mouse listener and mouse motion listener, whatever we have overridden. Okay. And these are the event handler for the various mouse events. Each method handles its event and then returns immediately, which is compulsory. Mouse events demo constructor also adds window listener. Okay. So window listener, mouse events demo constructor also add a window listener into that. Okay. To enable the program to respond to window close event when the user clicks the close box like system.exit 0. This listener uses an adapter class to implement the window listener interface. Okay. So this listener has to use the adapter class to implement the window listener interface. Adapter classes supply empty implementation of listener interface, enabling you to override only the method or methods in which you are interested. Okay. So empty implementations are provided by adapter classes. So whichever methods you are required to implement, those only you will implement. It is not compulsory to implement all the methods. Okay. So which are the methods, detailed methods we will see in detail in this particular chapter. But here one we have used, that is system.exit 0, to greatly simplify the code needed to close the program. And what is the code? System.exit 0, because AWT GUI based programs will not be closing immediately or automatically. You have to implement it using system.exit 0. The window closing method is overdone. Okay. This method is called by AWT when the window is closed. System.exit to end the program. Now we will see the mouse event handler. Each time mouse event occurs, message is assigned a string, that is new string, and which will describe what happened, and then repent is called, and repent ultimately calls the tell the AWT to call paint. Okay, this process is examined. We will see in the later in this chapter in detail. Paint has a parameter of type graphics, which is compulsory. Paint method you cannot omit, you have to implement. Okay, so in this class we will see graphics context of the program. It is required for output. To display the output, you have to take the graphics object as a parameter. Without graphics object, you cannot display the output. The program uses drawString method that provided by graphics to actually display a string in the window at the specified X and Y coordinate location. Then drawString message XY. Message is a string to be output beginning at XY. In a Java window, upper left corner is 00, as we have seen in the I have explained some time ago. X and mouse Y keep the track of the location of the mouse, that is current location of the cursor. Okay, these values are passed to drawString to update the string. Okay, the program is started by creating mouse events demo instance and then setting the size of the outer window, its title, and making the window visible. Okay, so these features we will see in detail in chapter 26. Seems interesting? Okay, so this topic and this chapter is very much interesting. When you will implement, you will enjoy it more. You will like it more, and you will tell that instead of that console based program, GUI based programs are very much interesting. Okay, because it all have components in the AWT GUI based programs. Okay, handling keyboard events. To handle keyboard events, so we will use the same architecture as the mouse event. Okay, we will be implementing the key listener interface in the keyboard event other than the mouse listener. Before looking that example, we will see how the events are generated. Key is pressed, key pressed is generated. Key released is generated. If a character is generated by keystroke, key type is invoked. Okay, each time user presses a key, at least 2 and often 3 events are generated. At least 2 means key pressed and key released, and more often, maximum 3 events, key press, key type, and key release events are generated. Okay, and which interface we have to implement? Key listener interface. Okay, if you all care about actual characters, then you can ignore the information passed by the key press and release events. So what matter for you? What matter for you means what is important for you? Only the key press and release is important for you to build in your Java application, in your Java program, or what is important for you is characters that are contained in that particular key that you are pressing or any user is pressing. So if you are dependent or giving importance to only character, you can forget about the key press and key release event. If your program needs to handle special keys such as the arrow or function keys which do not generate any particular character, then it must watch for them through the key pressed handler. Okay, so now we will demonstrate the keyboard input. It equals keystrokes to the window and shows the press release status of the each key. Okay, so related to keyboard event we will see in the next chapter. Till then you can enjoy the event handling process. Okay, meet you in the next session with the next theory part. Thank you so much.